My name is Doug Balcomb, professionally usually known as J. Douglas Balcomb. I have a doctorate in nuclear engineering from MIT in 1961, and after I graduated from MIT, having done my thesis work at the Los Alamos National Laboratory, I went to work there as a member of the staff and continued to work at Los Alamos for 27 years. A fantastic place to work, all of the resources you can imagine, marvelous people to work with. It was really an incredible experience that was unique. I thought, you know, most places would be like that, and I found out later after I left that Los Alamos was just the most amazing place to be. And it allowed me to develop the kind of interest and follow it through in solar energy just because of the attitude and the way things work there. And I'd like to go through that a little bit. With my nuclear engineering background, I joined the group there that was developing a nuclear rocket engine. This is an amazing device that was designed for a manned Mars mission. And a nuclear rocket engine would be about the diameter of this, the core of it anyway, about this table, a yard or so, a little bit more in diameter and tall, made out of graphite with niobium-clad holes through it, operating at roughly 1,000 megawatts. That is something like 100 times the power density of any nuclear reactor that had been built. An astounding amount of energy in a small space, the purpose of which was to heat hydrogen from cryogenic, that is liquid, up to 3,000 degrees so that it can be expelled out through a nozzle at the end of this core. And we tested these in the desert in Nevada, just over the hill from the testing Yucca Flats. We were in Jackass Flats. Anyway, that was quite an experience. And my responsibility as an engineer was to model the performance of that system, and using computers well before PCs, the big Cray computers that we had at Los Alamos to model the performance of that rocket engine. So we could start it up, shut it down, do all the what if tests, what if something went wrong, how would we cool it, and so forth. And that was my responsibility as a modeler, a lot of math. And it was exciting. I was working with about 250 different engineers with all different aspects of that, from the metallurgists that made the fuel and the other people, fellow engineers that worked on the controls and so forth. And that project came to a conclusion in about 1972 because funding was canceled. Well, this was just after the 1969 moon landing, and the funding for NASA went down. And NASA had to decide, are we going to continue this project or the space shuttle? That was the decision. And of course, the logical conclusion of that would be, let's do the space shuttle. And so they phased out the nuclear rocket propulsion program, and we just all, in a fairly short amount of time, were looking for other projects. And Los Alamos was good at taking care of its own, and almost all of the people working on that went off on other things, and I was asked by my division leader to head up a little group of sort of a brain trust looking at new kind of technologies that we could develop. And we looked at superconducting power transmission lines and superconducting magnetic energy storage, and we looked at ways to gasify coal using nuclear reactors, and we looked at space propulsion, other techniques using small blasts from a thermonuclear explosion by imploding a pellet, and all of these kinds of incredibly high-tech, spacey kind of things. And in the middle of all of this, I went out and attended a solar conference, at the ASES, International Solar Energy Conference, I think in 1973 in Los Angeles. I'm not quite sure, but this I thought would be a good idea, find out about this, and got kind of excited about it, came back, talked to folks about it, and came up with the idea, well, we could build a better solar collector. We knew how solar collectors was done, the HODL kind of things that were developed at MIT, and we'd like to integrate the solar collector with the roof. And so good engineers, we knew how to do all of these kinds of things, and we engineered that and managed to get funding from Washington to work on this. This was before this was back in the AEC days, before the Department of Energy was formed, and got funding. And one thing developed into another, and we ultimately took that idea, built a 6,000 square foot roof on the new library, which was being constructed at Los Alamos. That roof, incidentally, is still there and still working fine. It was very well engineered and very expensive. And we came out of that with the feeling that although technically this is feasible, it probably isn't transferable to the building sector. Of course, we didn't know anything about the building sector, but we were learning fast, and so we got funding to do different kinds of things. One of them was, of all things, to put solar collector and solar systems into modular houses, and we learned about the modular housing industry and so forth. And meanwhile, in New Mexico, there was all of this other stuff going on. And there was Drop City, and people were out there excited about, you know, how can you heat your house with these systems. And some of us referred to that as the flapping plastic era of solar energy. And mostly air heating systems and so forth. And there were folks like Steve Baer who was developing these ideas. And most of the people who were in Washington providing funding for this were working on active systems. They didn't call them active systems originally. That came out of the idea, by contrast, that systems that didn't have all of those mechanical things would be passive. I think a term that I always attributed to B.T. Rogers, Buck Rogers, I think, who came up with that contrast, which I thought was always marvelous. And so I started kind of looking at, well, what's going on there with all these passive systems in New Mexico? Is there anything to that? They seem to work, but of course nobody had any numbers or data. It was all anecdotal. And so I started kind of looking around and asking questions. I knew of a system that had been built in Odeyo in France, down where Felix Trom had his big solar furnace. And as a kind of fun side project, he'd built this house with the Trom wall. And I went to see that, and there was a building up in Liverpool, England, that was a passive solar school, and talked to the folks there. It was pretty clear that these things were working. You know, they were actually working. And they weren't using any high-tech approaches, but they were working fine. And so we said, well, we've got the computers. We could model these things. We're modelers. We know how to do the diffusion equation and figure out how things flow around and so forth. And we started modeling the passive solar systems that people were doing. And we didn't invent anything. We just tried to understand how things were working and put numbers to it. And ultimately that led to passive solar becoming credible, not in the eyes of the people who were doing it, who knew it worked, but in the eyes of the people who provided the funding and the engineering community, and ultimately the architectural community, which were the people that really mattered because they were the ones that had to implement it. And in the course of that, got tied up with people who were interested in putting together some kind of an organization. And Keith Haggart was the key person there, a marvelous man. And Keith was the ultimate integrator. He knew somehow how to bring disparate people together in order to get a common goal. And probably the two most disparate people were myself and Steve Baer. Steve hated the government, fundamentally kind of an anarchist at heart, and the very idea that the Los Alamos National Laboratory, the antichrist of the whole weapons and establishment, was working on passive solar. Give me a break. I mean, he was just livid about this idea. And so, not personally, but just, you know, in terms of philosophy, he was counter to this and didn't want anything to do with that. Over the years, he and I came to terms, became friends, and somehow had an accommodation. And finally, years later, I invited him to give a lecture at the National Renewable Energy Laboratory, and he came up to Denver and gave that lecture, and we had a room full of people who asked him a lot of questions about how his systems worked, and he was just marvelous. And he was a little uncomfortable working in this federally funded environment, but he did it, and that was great. And Keith was the kind of guy that allowed that to come together. And Keith Haggart and others came up with the idea of a New Mexico Solar Energy Association, and I was one of the founding members of the NMSEA. And Keith was the first chairman of that organization. That was the organizational framework that I think allowed us to be effective. And they had a big group of people headquartered in Santa Fe putting out the Sun paper. Was that the name of it? The Sun paper. Yeah. And I contributed articles to that. And what a mix of things. My graphs with showing performance and how things work, coupled with other people's almost philosophical papers about how entropy. Wonderful this is. And what we did was show that the passive solar approach was comparable in efficiency, how much energy you can actually offset for heating buildings, with the active solar systems. And we did that through monitoring many buildings. And a friend of mine, Stromberg at the Sandia Laboratories, published a series of books, or 2 or 3 of them, there weren't very many, which was just chronicling the development of various passive solar buildings. And the fact that that came from the Sandia Labs helped a lot in making passive solar credible. And then Bill Mingenbach from Taos, an architect, and I pulled together the first passive solar conference. I got $35,000 from the then Department of Energy in Washington to put that conference together. And about 700 people came. There was this mix of folks, and they came from all over the country. A carload of hippies showed up from California. What's happening here? And this is really great stuff, and we understand something's going on. In fact, something was going on, and the proceedings of that conference are kind of collector's items today, I think. That was a lot of fun because it had this integrative nature, and there was a person came out from Washington to see what's happening here too. And as a result, the funding from the government, the Department of Energy, for passive was on parity, was equal more or less in amount by the late 70s with the funding for active solar. And it made an enormous difference, and we were able to put out the handbooks and that sort of thing. Again, we didn't invent anything particularly, we just tried to quantify it. And those handbooks put that in a form, the simplified method, the solar load ratio method, that was a simple way of, before people had desktop computers that could do the hour-by-hour simulations, they could do monthly simulation with handheld calculators, which were available at the time. And so that made an enormous difference. It was just great. And to me, I had been working on this project that was secret for reasons I never totally understood, because it didn't have any defense implications. But anyway, it was classified. So I couldn't talk to people about it, and even among people I talked to, they were impressed that I was working, you know, he's a space scientist, he's a rocket scientist, but they didn't understand really what I was doing. And to go from that into a field in which you're talking with people about where they live and the comfort of their homes and the lifestyle that goes with that and the energy savings that goes with that was such a transition, because all of a sudden I was talking about things that mattered to people. And that mattered to me. It made me very comfortable, and people would come up to me all over and thank me for what we were doing, and that was great. And we, just to kind of get an experience, and because it was a fun thing to do, we bought a house in Santa Fe that Wayne and Susan Nichols put together. The architect of record was Bill Lumpkins. They needed to have an architect stamp, and it was a kind of collaborative effort originally. I think Ming and Bach and others had something to do with the concept design of that solar greenhouse house. And we didn't design it, but I did monitor it. We lived in it 7 years, and it was 89% solar heated. I published papers on that, and it worked beautifully. And here's a system with almost no moving parts that took care of itself. And about 32% of the energy that came through those south windows of the greenhouse wound up offsetting heating needs of the house. What that meant was that we could heat the house for $70 a year of electricity, where our neighbors, non-solar, in other subdivisions were spending $1,000 a year for heating their house if they were off the grid, off the natural gas, I mean. And so that was important. And it was also important because that house was attractive. And we had a couple thousand people who came through and looked at it. And I have publications from all over the world showing pictures of that house, and kept
Life magazine,
including a centerfold of the Life magazine. And
yes.
It was certainly exciting. And people took note all over the world. What's this passive solar stuff? And I was invited and lectured on passive solar in 32 different countries, sometimes more than once, and involved in International Energy Agency projects. And it was a heady time. You know, I had my 15 minutes of fame about that time, and eventually the funding went away again in the early 80s. And I was given an offer at the National Renewable Energy Laboratory, which was originally the Solar Energy Research Institute, and took that offer and went up there and finished my career there. And I continued working on passive solar. In the mid-'80s, late '80s, there were 2 or 3 of us in the whole country were still doing research on passive solar. And a lot of folks like Mark were doing the implementations. And I got originally involved with Ed Masria and the Nichols in doing, pulled together a group called Passive Solar Associates. We did 30 workshops all over the country in different cities, and we're responsible for educating about 3,000 of the architects and engineers in the science and the construction techniques and the architectural aspects, because that were our three specialties. And it was a lot of fun doing that for a few years. And I think a lot of those folks are still, the original ones got some of their formative ideas. Worked through the ASES and was active in that organization and in ASES, and did workshops at their conferences as well. Boy, I went on for a long time.
That was wonderful, Doug. And you know, I remember back in 1974 when I came on the scene, I was working with Peter Van Dresser, Buck Rogers, Keith Haggard, David Wright, Francis Westling. And it was the Sun Dwellings team to look at the feasibility of integrating very simple technologies into the construction characteristics of northern New Mexico. And budget was very, very important, materials, and Peter Van Dresser's, philosophy of how are we going to use technology to keep the social economic fabric of the northern New Mexico villages. And as an architect, I started working with Bill Lumpkins and David Wright, who was working with Bill at the time and then just left, got his license, went on his own, and I kind of sat in David's chair. And the first project I had was redlining the Balcomb house. That was on the boards in Bill's office. We also had the Sun Dwellings program. And as architects, we were really, really interested in passive. And Peter definitely believed in passive. He's been living with passive for 20, 30 years. Bill Lumpkins, as an architect, designed his first solar adobe in 1935. And always integrated passive techniques into his buildings without even telling the clients. He just did it. And his buildings were just
didn't
wonderful.
Use that terminology either.
No, didn't necessarily use the terminology because it really didn't come around. And I kind of agree with you, and I think that was Buck who came up with the term passive solar. And we started to have the conferences up at the Ghost Ranch where people would come and talk about projects they've been working on or places they were living in. And there was kind of a little bit of a rift between the passive people and the active people. But as part of the passive group and part of being an architect, the challenge was the building is the machine. And how can we utilize the building to do what collectors do so we don't have to go to the cost of collectors on top of the building? And so we designed what we could, and the first ideas were, as you saw in David Wright's Sunscoop house, was design the house and add as much south glass as you can stick into it. And the more, the better. And then we realized that, we created a machine that would really get too hot, and then it would get really too cold. And we really needed design tools to help balance the direct and indirect apertures of our buildings, how to balance that with the insulation and thermal mass, which we knew we had and did something. And so David Wright and I started to develop a very basic heat loss versus heat gain calculations just based on simple ASHRAE heat loss calculations and solar gain as it would come through glass. And it wasn't totally valid. We couldn't balance in trom walls in daytime and really predict temperature swings, although we did come up with some numbers. But it was really primitive and just gave us a way to compare one building that we designed to another. And then you came in on the scene and saw that there was a real need for validation, and we needed tools to design to, number one, convince our clients that it would work, contractors, and state and city officials to say, yes, this technology does work. And so Doug and his team up in Los Alamos really worked on developing the builder guidelines and the sensitivity curves that we utilized to start really taking this as a science. And as soon as we had those numbers, it became a science rather than a guessing game. And so I thank you very much for that, because that's what really got my career going, and it was a tool that I used most of my career the builder guidelines and the solar load ratios. I actually had to rewrite the whole program for my Macintosh computer because it only came out for IBM in those days and nobody cared about Macs. So we rewrote it and I used it for 15, 20 years till Energy 10 came out, which was the next phase in the development of analyzing passive solar. And so these tools were just incredible. And now we can go to different parts of the world, utilize actual weather data, predict performance, compare it to buildings that were already compared, or analyzed, and we know that they worked. So it gave us the tools to really explore and develop technologies. And all the other ideas and philosophies that came out of the Ghost Ranch Conference was just amazing, and all the different attitudes. And as one that loved that, I was there every year. In fact, I lived there at the ranch because I was working on the Sun Dwellings buildings. So I felt like, a host to the world. And people would come and we'd give tours of the Sun Dwellings and what we did. And, it really followed into the philosophies of Peter Van Dresser and Bill Lumpkins that here we are in northern New Mexico and that's how we had to build. So there wasn't any plywood in those buildings.
All natural materials.
All
from
natural
the locality.
materials. We built our own windows. We built our own doors. I can't say they totally passed, codes now.
The insulation
but it
was
the technology.
pumice
Pumice in the walls.
from the area.
Yes, pumice under the floors, and we used sawdust in the roof.
Yeah.
And after 30 or 40 years, I have gone back and looked at that sawdust, and it is still just fine. No mold, no moisture, and it's still doing its work. And a lot of that came out of the Forest Service. They did a lot of research, and Peter was very much into that and knew the insulating values and said that's what we got to use. And Bill Lumpkin said, totally, why not?
And the Sun Dwellings team wanted to monitor the performance, so they came to us and
Yes.
We agreed. And so we showed up on the site as they were being constructed, and we strung thermocouple wires around through the adobes as they were being laid. And people would quip that this was the only thermocouple reinforced adobes in the world.
Mm-hmm. Or the most high-tech, low-tech buildings in the world.
So we took data on how they worked, and we compared the three buildings with the control building. There was a direct gain, there was a trauma wall, and a sunspace design, and then a conventional design, which was the control building. And the passive solar buildings all worked very well. The sunspace building worked a little bit better because it had a larger glazing area.
Yeah.
And I always was partial to the solar greenhouse approach because it serves multiple functions, and you can grow plants, and we did in our passive solar house in Santa Fe when it's right through the winter with no backup heat in the greenhouse. When it's 20 below outside, it's still it never got lower than about the high 40s inside the greenhouse, so you could grow vegetables and flowers even right through the winter. In Santa Fe, that was just a revelation. And of course, Bill Yonda was promoting that idea as a retrofit primarily in buildings all over northern New Mexico. And his wonderful book, The Food and Heat Producing Solar Greenhouse, was a bestseller and is influential today.
Very much influential. I saw a greenhouse in Del Norte, Colorado.
Yeah.
It looked like it was probably built within the last 2 or 3 years. And it was definitely the exact greenhouse that Bill has in his book. So I felt really good about that. And I'm going to get a photograph for Susan yonder to share with her. But I was part of some of the earlier Passive Solar Associates workshop. I came up to Denver to take that program. And as much as possible as an architect, I tried to educate myself on the technologies and tools that were available to help us design. And what came out of the Ghost Ranch monitoring, because I lived there for 2 winters. So not only do they have the ability to look at the thermocouples and say, okay, that's 73 degrees or that's 53 degrees, and I'm freezing. So I knew limits, I understood comfort, I understood the buildings not only from just looking at the numbers, but actually living in the buildings and being able to compare the temperatures of the buildings with personal comfort. And what came out of that was there was no favorite between sun space or trom wall or direct gain, but the direction at that point was integration of all of them and use, because they all had little advantages
And they complement
disadvantages, and they complement one another, and we learned that from the Ghost Ranch project.
Yeah.
So ever since then, everything's been a blend and a hybrid of various technologies. And they just keep getting better and better because we keep learning more and more and seeing what other people are doing in different parts of the world.
The advantage of monitoring these things is you can validate the computer models that we have. And that proved to be vitally important. Stan Moore and came up with the idea, and we built 14 passive solar test rooms at Los Alamos. And these were little buildings that were 5 feet wide, 10 feet deep, about 8, 9 feet high, foam insulated test rooms. And in each one of these we could put a different strategy. We had the direct gain test room, which had the mass lining the walls and the back and the floor. Trom wall test rooms with the mass out in front, both with and without thermal circulation through the vents. Even sun space test rooms. With 14 test rooms, you can do all kinds of things, and we took data on those and compared the backup heat that was required to keep them at a fixed temperature, and that was the basis for validation of our computer models, because we could get very precise data, and our models track those ups and downs, and we also learned that the fact that, well, you don't want to put a thermocirculation system in a trom wall, because that just heats the house during the day with hot air. The direct gain can do that better and more comfortably and more aesthetically. Those vents were a nuisance. Insects got through, cobwebs in the vents. What are those holes in the wall? The person would ask. You don't need them and you don't want them, because the heat from the trom wall comes through into the evening, and that complements the daytime heating of the direct gain, and the two mixed more or less equal proved to be a wonderful match. And so we found out a lot just by that. And it was the experiential aspect of this, and that was one of the important things for us in living in the house in Santa Fe. All of my other colleagues were just doing the numbers. We were living it, and that was probably equally important to my education. Golly, this thing works. It's comfortable. It takes care of itself. We just opened a vent in the summer. It didn't overheat. And closed that vent in the winter. And it provided almost all of the heat. And it was a marvelous space to boot that people loved.
Yeah, that was the second phase, I think, is understanding the human interaction with the systems.
Yeah.
And we realized that with trom walls, the first year clients would go 10 minutes to sundown, let's go close all those vents. And they'd run around the house and they'd close them, and they go, let's get up early because the sun's going to rise, we've got to open up all those vents. And the next year it was, what do you think, babe? Why don't you just go open those vents for us, or just go close them? And then by the third or fourth year, they had furniture up against the vents and weren't bothering. And everybody saying, well, maybe there's a better way of doing it. And I think it was Doug that came up with a fantastic check valve with a window screen and a piece of dry cleaner plastic.
Yeah.
That just worked one way, and it was just marvelous. And every one of us in New Mexico
I think it was Bill
loved it.
Dingenbach that came.
Bill came up with that, but
we tested it.
It was wonderful, but, and really fit with New Mexico technology, using materials like that. But again, it was just kind of a band-aid to the human interaction.
Yeah.
And then we realized that the walls and everything would be much nicer if we just eliminated that and just let the trom wall do its thing, drive the heat in. We use it for nighttime heating and balance it with direct gain for daylighting and day heating. So it was just a marvelous marriage of ideas and ways of looking at things that brought the technology along. Yep.
Want to get some lunch?